This is cs517A. For this video lecture, I'm going to talk about CPU scheduling. CPU scheduling is the assigning of CPU resources to the processes and threads. The OS will optimize the CPU resources while at the same time giving equal opportunities for the processes and threads to use it. A scheduler is what carries out the scheduling activity. Schedulers are often implemented so they keep all computer resources busy, like a load balancer. Allow multiple users to share system resources effectively, or to achieve the target quality of service. A dispatcher is the module that gives control of the CPU to the process selected by the scheduler. Types of CPU scheduling. There are actually two types of CPU scheduling. The first is preemptive scheduling. In preemptive scheduling, the tasks are mostly assigned with priorities. Sometimes it is important to run a task with a higher priority before another lower priority task, even if the lower priority task is still running. The lower priority task holds for some time and resumes when the higher priority task finishes its execution. Second one is non-preemptive scheduling. In this type of scheduling method, the CPU has been allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching context or terminating. It is the only method that can be used for various hardware platforms. That's because it doesn't need special hardware, for example, a timer, like preemptive scheduling. Some CPU scheduling criteria. The following criteria affect the performance of the scheduler. So first is CPU utilization. A scheduling algorithm should make the CPU always busy. Next is fairness. A scheduler should give processes and threads equal chances to use the CPU. Third is response time. A scheduler should maximize response time for the processes. Response time is the duration between the submission of a request and the response to that request. Fourth, throughput. A scheduler should maximize number of jobs done in a given time. Throughput is the amount of work completed in a given time. Next, turnaround time. Turnaround time is the time between the submission of a process and the time of its completion. This is an important criterion for an efficient scheduler. Last but not the least is waiting time. A scheduler has to minimize waiting time. It is the time when a process waits for resource allocation when several processes are competing for resources. Here is a list of some scheduling algorithms. I'm not going to discuss them here because I'm going to ask something from you. This is a requirement for this week. So you have the first come first serve, shortest job first, priority scheduling, round robin. Personally, these topics are the ones that I can always remember, even if I was not teaching OS before. This is what really stuck stuck in my brain is the scheduling, because there's something to do with solving some stuff. Okay, so to recap, CPU scheduling is needed to optimize the use of the CPU resources. This is done without compromising fairness in serving the multiple processes and threads. So for further reading and viewing, please visit the sites listed. Thank you.